DMAIC, Making It Work, Mahzad Pakzad, December 2nd, 2016. I did this because I desperately need a job now. Topic: Use of DMAIC to support product robustness optimization. DMAIC enables a structured problem solving and project management for quality improvement. Define stage, opportunity to describe objective, scope, resources. First, there will be preliminary, then progress stages. Major stage, an opportunity to identify and set critical to quality specs. First preliminary stage, then progress stage. Analyze stage, opportunity to evaluate the design, process engineering. Examples are validation plans, qualification plans, tests, design of experiments. Improve stage, opportunity for continuous improvement and CAPA, applying concurrent engineering to align design and process specifications. Applying design for excellence principles to modify design as needed. Control stage, an opportunity to strengthen quality management system towards total quality management. Examples are documentation control, design history files, supplier certification, validation plans, statistical process control. Use of DMAIC to support product robustness optimization. I picked an example for you here, how DMAIC can be applied. The presentation is based on that example. First section of presentation is overview of chosen project, how it could be categorized under DMAIC, and how it supported product robustness and quality optimization. Second section is process capability evaluations. Third section is capability evaluation status report. Fourth section is design of experiment. Fifth section is design for manufacturing, design for assembly, design for cost. Sixth section is Lean Six Sigma. Seventh section is equipment design and PM, project management for preventive maintenance upgrade. Eighth section is bulleted project outputs and results. Ninth section is recommendation letter from the company that I did this project for. 10th section are supporting documents, my presentations posted online. Okay, first section, step 1, Six Sigma Black Belt Project Summary. The chosen project for this project is a Six Sigma Black Belt project for an automated cell. I was hired as consulting manufacturing engineering to manage the project on a 6-month assignment. I was the champion for the project, reporting directly to engineering manager and indirectly to all senior staff, including quality director, plant controller, plant manager, strategic planner manager. And I had the team meetings with everybody from production setup level to tool maintenance, purchasing, suppliers, and of course work very closely with design, process engineering, and quality team. The automated cell included a gantry robot unloading the molding machine and loading the automated cell, injection molding process including all influencing factors such as materials, plastic, rubber, molds, and auto feeders were part of the process evaluation. A turntable with several assembly sections, stations including robotic pick and place, folding mechanism, pressure insertion, vision inspection, offloading station, additional robots, and different controls including Allen Bradley controller. An operator at the end of output conveyor, unloading parts, inspecting, packing, or rejecting them. A secondary inspection team that certified parts for customers. Problem statement: customers were receiving unacceptable parts. Scrap rates were high, so was the equipment downtime. However, there were no well-defined data on why output quality was inconsistent or where the process was out of control, or why equipment was breaking down frequently. We had hidden problems. Problem solving approach. I identified and used necessary Six Sigma tools for systematic analysis in my evaluation, but decided to use a bit of creativity, modifying standard analysis tools to match the product process analysis to them. Instead of using standard formats and forcing data fit in standard tools, I work closely with cross-functional teams in-house to ensure understanding of all issues and requirements and made sure they bought out on my solutions and supported their development by proving to them that we could improve quality by improving process reliability, added control over operations, and enabling visibility over problems. This included preliminary demonstration and training, proving that they could easily operate and maintain the recommended automated and semi-automated methods for detecting rejects and repairs of tools. Then I had regular meetings with management, updating them with my progress through presentations. Define. Unfortunately, defining problem statement is not always easy, especially for complex modern mechatronics products. It wasn't unusual that people hadn't yet had an opportunity to observe and recognize the root cause of problems. For such products, one needs to gather all possible data about compliance issues as well as known critical to quality features. Perform some analysis before being able to say how long or how much is required for project completion. In summary, a comprehensive problem statement may be difficult to develop without thorough evaluation of processes. This may include design of experiment in some cases. Measure. Although supplied parts may be the root cause of the problems, but as long as no one has identified all critical to quality features and factors, no one could know all criteria that need to be measured by suppliers for quality assurance. Engineering evaluations analysis to identify all CTQ features factors that need to be measured may be most critical part of DMAIC and requires cross-functional skills and the ability to communicate data using innovative and clear methods that cover all details impacting the quality. Experience has found the following and more issues with measure. Many choose the wrong features for measure. Many calculate the piece cost only, not the bottom line cost. Many use an unclear, inadequate baseline for quality expectations. Many use inadequate method for measurement. Many do not know how to properly use measurement tools. Many make mistakes interpreting data or overlook data. Analyze. In order to perform a comprehensive and accurate analysis, one must have the technical know-how to study parts, processes, equipment, tools, procedures, with the ability to understand science and technologies required to build their products. This again requires a cross-functional and knowledgeable, experienced engineer and designer who not only can understand issues but can translate them and communicate them with cross-functional teams. Best analysis methods are validation plans normally developed by design of experiments. They help qualification of suppliers, and it is best to perform them during design and development in order to support product robustness optimization. Improve. There are many reasons that improvement plans do not work. Here are some. There are no clear definitions of what the root cause of problem is. Yet people start working on improvement plans. The solution is forced onto users without their buyout. The solution is developed by contractors who leave the company and no one in-house has training why and how the system was developed. Then a product process change requirement comes along and then people don't know how to make the change happen. Another problem is the problem that needs improvement on is not carefully studied when making new plans, resulting in overlooked details. Other problem is that the problem needs improvement. The problem that needs improvement is high tech, requires deep scientific and engineering analysis, but management leave the problem solving to people who with no innovative new problem solving methods, experience, or high tech background in engineering. Another problem is the management avoids investing on new tools, equipment, worried about justification, and they use the lower cost solution methods, resulting in not solving the problem as needed. Innovative engineers could develop workable and justifiable solutions. DMAIC overview Six Sigma Black Belt project control. Control over quality must be designed into product design, process design, or at least procedures. Manufacturing is a dynamic environment. Variations are to be expected. This could be a variation of incoming material part, process equipment, wear and tear, changeover, physical displacement, misplacement, environment changes, or using different operating um, methods and procedures. An experienced engineer could apply concurrent engineering during design of experiment validation and other engineering analysis to identify methods tools required to monitor and control the CTQ for the product process in the most effective and least costly managed. Actually, in different project, I had responsibility for managing NPI projects. I increased the productivity 50% by making sure that the NPI projects were managed properly from the beginning, and all the new products were released to the manufacturing with adequate tooling and detailed procedures on how to handle the assembly operations, the fabrication operations. So NPI, design and experiment, validation, all of that can have significant impact on production control. Section 2. Use of DMAIC for the specific project that we are discussing here, which is a system integration of an automated assembly equipment that includes injection molding machine. First thing started doing was identifying issues, list of issues. What are the hidden product process, design feature, and critical to quality? So one issue was that we didn't have a complete list of issues. That was an issue by itself. There were no complete list of the issues. Next one was what are the not measured, undocumented variations of parts and process assumed acceptable. So we knew that we were accepting parts we shouldn't have, but we didn't know what was it that we needed to measure and consider critical to quality. It wasn't identified. And while we were having machine downtime, nobody knew why the machine breaks down. Why we have devices and automated equipment that are not being used? Well, I had made a visual inspection of the equipment. I could see that there are devices there that they're not being used. I didn't know why. Why we have scrap and why some of them are not being detected at work cell areas. What is the effect of these variations from each step process to next step process? So we had inconsistency, quality, and operational inconsistencies. We didn't know each inconsistency, how else besides impacting what was happening at this station, how else it was impacting the rest of the system, and what was the real cost of the quality. First thing I did was try to organize what was happening with product design. For product design, fabrication, assembly methods, process equipment, system integration, output. I try to make sense of what goes on through a different stage and how is design for manufacturing, design for assembly applied to control the quality throughout the process. First thing I did was I identified influencing factors. It was part design, then it was the molds, There were molding machine and then the assembly equipment. And as a result of my study, I put together a report for the management. With approval of my manager, we decided that we broaden the objective to identify all factors that can affect the operation and quality of output parts for automated cell, then develop requirements for running the system cell to maximize efficiency. Following this reviews some of the output that can be expected out of the studies after completion. This presentation reviews the system complexity in order to identify and the general analysis data required. Basically, what I was trying to do, gather data that the company didn't have. And I was trying to explain to them why we need to gather this data. Why am I asking for data that they're not using? So I had to justify collecting data, what I needed and why I needed it. So first thing was develop a systematic analysis customized for this project in order to identify issues clearly and completely, and then identify all of their possible causes. Also identify the design for manufacturing, design for assembly, and quality engineering requirements to maximize productivity and support Lean Six Sigma as much as possible. Next, understand the impact of product design on manufacturing, then identify necessary design specifications, features for supporting consistent manufacturing, and robust output quality, both during molding and assembly operations. Example, do we need to straighten the area between insertion tabs on parts in order to control tab location, or vice versa? What are the tolerances on the parts coming out of mold that affect assembly machine operation? Understand the variations and impact of incoming material on quality of parts and machinery. Understand mold and molding machine in order to avoid serious molding issues or damage to mold. Identify all risks caused by automated equipment failure and have a plan to take action as required. Develop, clarify functional specifications, requirements for devices, components, and the system as a whole. Understand production related issues, machine downtime, run rates, manpower, training requirements, environment. Understand maintenance and setup requirements for the system in order to run in production with no minimum unscheduled interruption. Develop standard procedures and training requirements. Collect data for performing failure mode and effect analysis, plan corrective action. So for gathering data for problems, I started with voice of customer, where the outside customer quality issues, fit, function, aesthetic, internal customer concerns, fit to assembly fixtures, automation problems, function, molded parts, they can change, dimensions can change, and if the parts had friction problems, environmental effects, equipment damage, mold tool damage, automated equipment damage, production downtime, production capacity waste, delivery issues, customer loyalty. The interesting part of it is that all of these problems were hidden. Nobody had questioned the mold damage. They had mold damage. It was a problem. It was a headache for molding department. It was a headache for production. But nobody had questioned where the root causes of our scrap problems. And I had to list these things and question them before people spoke up. Oh yeah, we do have a problem here. The next thing I did was analysis of what's going on inside the mold. I looked at the mold, it's very complex. The mold itself was an automated piece of machinery within the molding machine, very complex operation of the mold. So if there was something going wrong in there, it was difficult to notice just by looking at the mold. So what I did, I took an analysis of everything going on inside the mold, as the mold itself was a piece of machinery. Then the next thing I did the overview of overall flow evaluation, finding the out of control variables and listing them. Once I identify out of control variables, I started doing a graphic presentation, and I identified on the where we needed geometric dimensioning and tolerances inspection, flagged the problem areas. Next thing I did was using my favorite Six Sigma tool, which is CPOC, supplier input, process, output, customers. I use this to align first thing I do is for the process, the sequence of operations. Then I align the inputs to supplier with supplier, and to the effect on the process, and effect on the output, and effect on the customers. It's a very good tool for finding root cause problem analysis. Next thing, I had identified and listed the specifications required to design and develop automated molding machine, tending, and assembly. Specifications of parts, dimension variations, tolerances, clearances, parts quality attributes, parts packaging, condition as presented to system, output quality requirements for each device as well as for customer, characteristics of each machine, device capability, flexibility, timing, maintenance, communication requirements, failure mode and effect of each device, mechanism, equipment, effects of failure mode for each on other device and machinery, system interlock failure, eject response and features, and system requirements, required production run rate, flexibility, speed, part variation, life expectancies, and serviceability. Then this was my plan to report the project status on a Microsoft project report for keeping the management up to date. Okay, the next section is project status report of weeks after my evaluation of process capability, more evaluation. So the objective in this report states that evaluate requirements, develop plans, initiate teamwork to maximize process capability. Goal, if possible, is Six Sigma output of molding machine work cell number 13. This cell is to set example for other work cells. Work cell, of course, included the automated assembly equipment. The report covers a status summary of our team effort in past 2 weeks to evaluate and improve process capability of PRV parts manufactured in work cell. I underline teamwork. It's always a teamwork in manufacturing, and going in as a consultant, maybe an outsider, but I have to become part of a team. And what I do is I enable the in-house team to do what needs to be done. Basically, I am a trainer. I am a technical problem solver. I bring the people together. I manage the people, so I bring them together, better communication, build a team together, and I guide and lead the team to do the project. So I utilize the in-house people, and I help them to do what needs to be done. The report includes process capability assessment summary, solutions evaluation of and implementation progress summary on evaluation of molding process robustness, summary on evaluation of assembly operation robustness. And in the summary, we have identified there are several variables in molding process and assembly area that are not in control. So they had several out of control criteria. I gave them a list of the weaknesses as well as the strengths. And in the next stage, I explained that doing a root cause analysis for some of the problems would take actually implementing preventive actions would take time. So I recommended let's implement a solution for detecting the rejects, the defective parts first. Implement that so we would stop sending bad parts to the customer, and then we would go on with the implementing the solving problems from the roots, which actually we ended up doing all of it in parallel. And I just came up with the presentation. Let's do the focus on inspection, and I gave them a short-term solution which they needed a better workstation for detection of the defects. It was very difficult to detect um, problem. Defectives were difficult to visually identify, and they needed better workstations in summary. And also, I came up with a solution for long-term automated, reliable, very reliable automated detection of the defective parts. And also, with working with the design engineering, we started research evaluating visibility of purchasing user-friendly semi-automatic optical laser measurement system for inspecting molds as relevant from the supplier of the molds and during production maintenance of molds. This tool is very important, must be correctly selected in order to truly and effectively help control over the tool quality. We will review concept with all when ready. Basically, I knew that the molds were some part of the problem. I had identified that. I studied the molds carefully, identified they were part of the problems, and part of it was because they didn't have proper equipment to inspect and repair the molds. So I identified, did R&D, find the proper tooling for them, replacement tooling, brought it in, and started the project to work on that. And I presented to management my analysis, different molding machines, on molding machines, on the cooling system, on the rotary machines. Basically, these are different mechanisms within the molding machine that affect the quality and the material. And again, the summary of what the problems are and why I am asking for the solutions. Basically, it's a justification for making the changes I was requesting. Nobody wants to make any changes. People are afraid of they keep implementing changes, but they don't get any results. So I was telling them what needs to be changed, why it needs to be changed, how we're going to change it, and why it will deliver results. I was giving them all the facts, so there were no question on that. Do we need to do what she's asking us to do? The next section is on a design of experiment. I had gone and studied the materials they use for this product, and I had came across the issues. I had bought out process engineers. He agreed with me we need to do more evaluation. Then I bought out quality, and then I got supplier involved, and basically I had to convince people. We had to reevaluate the specifications for materials we use. And first thing I had to convince them with was is running the design of experiment. Second was replacing the material. Fortunately, design of experiment proved clearly that we needed to change our material. Basically, the reason was mill flow rate. Two problems with it. One was the temperature required was too high. The material was very difficult to melt. And the other problem was there was an extremely wide variation between lower level and higher level of mill flow rate. So basically, I had to explain everything to the management team to get their buyout on running the test and implementing it. And suppliers were very great. Suppliers helped me. First, they were resisting because they said I'm criticizing the material they're sending to us. First, they were defensive. Are you criticizing our quality? Then I explained to them, no, it's not your quality, it's how we use the material, how we specify the material. And really, we didn't have a good specifications for material. And I got them to work with me on finding out what are the better specifications, and they were very helpful after that. And we worked together, and I put together the first proposal, and they worked with me to make it perfect. And we came up with the plan and we implemented it, and we were successfully able to find the replacement material at no cost, no additional cost. Next section, I brought the company's attention to design for manufacturing, design for assembly, design for cost. Summary: as an effort to align design and process capability to continuously manufacture the PRVs per design specs cost effectively and on time, we propose identifying and adding tools that can be used as additional technique, skill, and proficiency by designers, engineers, and managers. Importance: it is presumed that all in engineering, toolroom, production, and management are making an effort to perform their jobs. It is known that we have productivity, quality, and delivery issues, mainly due to maintenance of molds and machines, which mostly should have been prevented and or planned for better problem resolution. Missing pieces are the lack of organized analysis, data collection, information management, and effective communication for better team support. Therefore, we propose to identify as many tools as possible to help us with analysis, data collection, documenting the information, and processing it to communicate among the team members. This is important to support both alignment of and improvement of the product's design and processes, molding, mold, automation, procedures, capability as required. So basically, when I got to the company, there was not a good communication between the production, engineering, management, and that lack of communication had disabled them to resolve the problems. And but everybody, of course, like any other company, they take pride in what they do and they're working very hard, but they're still having problems. My logic was, if you all are very good, which I'm not questioning, everybody is good, I'm not questioning everybody is working hard, but we do have quality problems, we do have delivery problems. I mean, that means we have a problem. And what I'm suggesting is the problem is that we are not documenting what we are doing. We don't have the right tools for documentation of problems. We don't have the right tools for analyzing, finding the root causes of our problems. We don't have the right tools for performing the corrective action, preventive action. So I justified why I needed to do some of the studies. We needed to some of the studies together. Design, develop tools to help us collect data, communicate data, and then do the root cause analysis. So the goals, I convinced them what they will get is enabling successful strategic planning for eventually eliminating the possibility of molding machine overloading, enabling the successful strategic planning for eventually eliminating the possibility of mold design issues, assuring design for manufacturing and design for assembly, maximizing mean time between failure for all process equipment and molds, minimizing machine downtime for repair and all process equipment and molds. I encourage them to go and let us do this because we have the knowledge to do this. We can do better than what they're doing. Personally, at that time, I was bringing 26 years of development and implementation of world-class manufacturing for automotive, aerospace, appliances, industries, and successful design and implementation of high-speed equipment, delivering quality parts on time. And the scope on that I was considering was adding tools to enable inspection of parts and molds to assist identification and documentation of design, process molds, parts, and quality issues. Also, adding tools to minimize pushing back parts data through the system, utilize voice of customer to apply it to develop tools for design for manufacturing, design for assembly, utilizing voice of customer to apply it to develop tools for program management, utilizing voice of customer to apply it to develop strategic planning. And then I came up with the improvement plan. First step, automatically check parts for short and flashes. These were molds coming out of the machine. I had identified equipment that could do the inspection automatically and have a portable and easy to use optical measure device for randomly once a week, once a day, check parts, dimensional variation after molding as required. Then develop an Excel tool for evaluating mold repair requirements. What is happening with the mold repair document, what they're repairing, how often they're repairing, how they're repairing, and find simple tool to use for measuring, checking the molds, dimensions, tolerances, flatness, wear, and identify critical to quality specifications that need to be added to drawings, mold drawings. They were simple but very important. The next step, I plan the next step for them all the time. And then next section of the presentation is on Lean Six Sigma, basically redesigning production floor layout, setup, materials handling, everything to implement Lean Six Sigma. I have extremely strong background in Lean Six Sigma. I actually think Lean is like a child's game to me, considering the projects I've managed. Lean is the easiest thing a company can do. And if lean is complex for you, that means you have a very complex operation. Complexity is not implementing lean, complexity is in the process design. And these are different, my method for lean. First, what is going on in the process, what are the issues, and where is the opportunity, what can be improved. First, I go with the process, it's different steps of the process, what is going on. And then for that step, what are the issues? For that step, what is missing? For that step, what can be improved? Same thing, continued. The last section, well, actually, it's not the last section, but the project last section is I had identified a way for identifying mold defects of the molding parts, molded parts, and it was a piece of automated equipment which we had to integrate with the system. And so I came up with it, convincing people to change. I'm sure everybody knows people don't easily change the processes. People don't easily accept consultants' um, recommendation to buy equipment. So what I did was put together, first found the supplier of the laser, asked them for a demo, and then got everybody's agreement to test the laser before we buy it and implement it. And I put together the test requirements as part of the automated equipment, temporary installation of the laser on the equipment for actual production real-time test. I put together the test plan. I gave them the work scope. I did this drawing. I have a control engineering background, electrical engineering background. I got help with the robotic manufacturer. I got help with the from Allen Bradley controller and all the requirements I needed. And from the laser people, I put this together, how we're going to interface the laser with the existing system temporarily for our test. And one of the weaknesses this company had, they did not understand their electrical diagram. And they were troubleshooting equipment without electrical diagrams, without ladder diagram. That was a serious problem, and I got hit trying to convince them they needed electrical diagrams, they needed ladder diagrams for troubleshooting equipment that breaks down all the time. So they were using try and error. And I got a lot of hit to convince them they need drawings, they need the ladder diagram. And this is a bulleted project results. One thing I was very proud of, I did very well there, was bringing the team together. Maintenance had serious problems with mold repair, and part of mold repair was in maintenance hand, part of it was in tool room hands, because complexity was huge complexity of the molds, and they had rotary platters. The rotary platters was attached to the mold, but it was considered maintenance issue, and these people were dealing with both design issue and lack of high-tech tools to do their job. And company management was relying that these people had 20 years experience. They used to build molds themselves, and they have everything they need to do the repair job. But the truth was that the tools these people used to build were basically a few pieces of steel blocks put together with cooling system inside. But these molds, this company was bringing the latest technology of the molding design in-house, which each mold itself is a complex piece of equipment, and they had not provided any training or proper tooling for the maintenance people, and they had left maintenance on their own to figure out what to do, how to do it. And those people are they just were complaining that this is difficult, this is not right. And management was saying, well, do it, difficult, do it. Nobody was coming up with a solution. So basically, that was one of the things I was proud of. So I worked with them, and I brought in exact tooling they needed and helped them to go back and resolve some of the design issues. That's the one thing I was very proud of being able to do. And the other thing was the better clarifying requirements to differentiate between good and bad quality. I see there's a lot of companies, there isn't a well-defined line between what is good and bad. So that was important to help the production people. They wouldn't have to struggle what is good, what is bad. Then work with the suppliers to control quality of materials for flaps. Flaps were one of the incoming components, and they had a quality issues, which was causing jamming of automated equipment. So we eliminated that, and we found out how to eliminate it at least. And work with suppliers, process engineering, quality and production, modified polypropylene materials specification, and limited its acceptable variation tolerances. This improved molding process operation and significantly reduced process variation. Change manual inspection workstation to add to operator visibility and reliability. Used innovation to make feasible using laser system that could reliably identify defects automatically, and got budget support from quality to work on the projects. Identified a measurement system for mold repair that could reduce repair time from 2 hours to 30 minutes, in addition to prevent human error using old tools. Modified equipment gantry loading parts from molding machine and flap loading station to minimize downtime. They had some drive issues, some mechanical issues, and electrical issues, electronic issues. Identified PM requirements and missing tools skills for preventing unexpected and extended equipment machine downtime. And this page is a recommendation letter from the manager I was reporting to. I have underlined his statement where that he says he was impressed with her being me, Mahzad Pakzad knowledge of skills in regards to applying Six Sigma methodologies and resolving several problematic issues. And the last page I have for you links to some of my presentation lines. First of all, I am the owner of Advanced Manufacturing Engineering Society. I started my career in 1984 as advanced manufacturing engineer, and that's how I help companies as a consultant. I study their products for design for manufacturing. I launch products. I manage NPI, manage product launches, apply design for manufacturing, design for assembly, design for cost, as well as bring into the company the best technology for process control, for running their operations smoothly without having to put a lot of efforts in doing what they're doing. This is one of the things, facts of life. If we make the operator's job on the production floor difficult, they will make mistakes. If we make it simple for them to do what you're doing, then they will be able to perform it um, better, that they deliver better quality when we simplify their work for them. So I do that for companies, and I use technology where possible, if required, as required. I do anything from product design, process design, equipment design, fixture design, troubleshooting, and I'm very good as an engineering manager, bringing people together, coming up with engineering solutions that solves problems for people on the floor, as well as delivers to higher management what they want. There are presentations I have on YouTube. There's also links to my blogs. And I am saying here because I know people like to grab my ideas and go and implement it themselves to try it all the time. I am saying here, I may be giving you the recipes, but you still need to have the artistic creativity, innovation, experience, and technical ability to deliver the results. So I have put this presentation together because I am in desperate need of work. I know my work is excellent. A lot of times when companies bring me for interview, they're overwhelmed with my experience, and the thing is that is why I am applying for engineering management, engineering director, because I know my experience just as an engineer can be overwhelming for a lot of managers who are hiring me. But it's difficult job market, I know that, but I do not deserve to be unemployed. Thank you.